Here are our objectives for 3.3. Just for the record, it's hard to say here are our objectives. Our. That's why I have to enunciate it. Yes. I'm trying not to be a pirate. Okay. Number 1, use long division to divide polynomials. Number 2, use synthetic division to divide polynomials. Evaluate a polynomial using the remainder theorem, and use the factor theorem to solve a polynomial equation. Okay? You ready? Long division. Okay. 6x to the 4th plus 5x to the 3rd plus 3x minus 5 divided by 3x squared minus 2x. So how do we set this up if we're doing long division? Long division looks like this, right? So 3x squared, that's exactly right. We have to have every exponent in the problem, right? So 6x to the 4th plus 5x to the 3rd, and then 0x squared plus 3x minus 5. Yes? Okay. So remember, when we're doing long division, we only really care about the first terms. So we say 6x to the 4th divided by 3x squared. Well, what's 6 divided by 3? 2. What's x to the 4th divided by x squared? Remember, when we're dividing exponents, we subtract, right? So that would be x squared, okay? So 2x squared, so I'm going to put it above the x squared term, okay? Now, if you want to be completely and totally technical, that is not required. Putting it above the term it's like is not required, but it helps us know when we get done, okay? So, now multiply. Multiply these two, 6x to the 4th. Multiply these two, 4x to the 3rd, right? Remember what to do next? What do we normally do at this point? We normally subtract, right? Well, if all I do is put a subtraction sign there, I'm going to remember to subtract this first time, but how many times am I going to remember this one? Less than all, okay? So what we want to do is almost like distribute that -1 to each term, because I'm subtracting each term, aren't I? So I'm going to put that there, and I'm also going to put that there so that we remember that we're subtracting each term. You okay with that? So then I have 6x to the 4th minus 6x to the 4th. What's that? 0. Guys, if you ever get anything besides 0 here, you did something wrong, because the whole purpose was to get 0 here. Okay? 5x to the 3rd minus 4x to the 3rd. Can I fix something real fast? I missed a sign. Can you see which sign I missed? 2x squared times -2x. So this should have been what? Already a minus, right? This should have been a minus right here, so that when I multiplied by the negative, it's not minus anymore, it is a plus. Does that make sense? Sorry about that, guys. Negative signs are my nemesis. Okay? So 6x to the 4th and minus 6x to the 4th, 5x to the 3rd, and 4x to the 3rd. So that is 9x to the 3rd. Okay? And then what do I need to do? I need to bring the rest of the terms down, right? Okay? So I've got 0x squared. It's still 0, but I'm bringing it down anyway, so I have an x squared place. Okay? And then I start all over again. First term by first term. It's 9 divided by 3. 3, what's x to the 3rd divided by x squared? X, so just 3x then. Plus 3x. Yeah? And now what? Multiply, right? 3x times 3x squared? 9x cubed. 3x times -2x. I'm not going to miss it this time. -6x squared, right? Now what? I subtract. I need to make sure I'm subtracting both terms. So 9x to the 3rd minus 9x to the 3rd. That's 0. 0x squared and 6x squared. 6x squared. bring down the next terms. Plus 3x minus 5. Now, since I wasn't going to even be using the 3x and the negative 5 until here at least, was it important that I brought it down right here? Not necessarily. I just bring it down so I don't forget anything or skip anything. Okay? Now we start over. 6x squared divided by 3x squared. So 2. So now multiply 2 times 3x squared. 6x squared. 2 times negative 2x. Negative 4x. And now subtract each term, right? Do you see why I made that a positive? Because if I'm subtracting a negative, isn't that adding? Okay? I just don't want you to be confused about that. Okay? Now combine your like terms. 6x squared minus 6x squared. 0. 3x and 4x. 7x. And then minus 5. I'm bringing down that 5. Okay? Now, you remember how I told you it was not necessary to put the 2x squared over the x squared term? But I said it helps us know when we get to the end. Like, are there any more spaces to divide? There's no more spaces, so I know I'm at the end. Because sometimes people don't realize, well, there's stuff here, so I still want to keep dividing, right? Well, if you think about it, there's no more place to divide, so what is this actually called? The remainder, right? The other thing that you would try to do if you tried to keep going, you would have 7x over 3x squared. Can you divide 7x by 3x squared? X can't be divided by x squared because it's bigger, right? So we are done. So when I go to write my answer, it's this plus my remainder. 7x minus 5 over what I was originally dividing by. And that right there is my answer. Okay? I mean, you can rewrite it again, but I figure I already have it written there, so I can just add on my remainder, and that's my answer. Does that make sense? Okay? Do you remember all the long division steps? We good with that? Synthetic division. You remember that? You liked that better when we did it in Algebra 2, right? What was the problem with synthetic division? Yeah, you can't do it every time, can you? When can you do it? Do you remember? Right. We can only... Here, let me write it for you real quick. This is the problem that we're going to do for synthetic division. X plus 3. So we can only divide if there's not an exponent here on the x. Right? So I couldn't have done this one with synthetic division, could I? Because it's x squared. Okay? Only if it's x. It can be 2x plus 3. We can do that. That's fine. Just not x squared plus 3. Or x to the 4th or something like that. Correct. Okay? So how do we set a synthetic division problem up?
Is that supposed to be 10x or just 10?
Thank you. Good catch. Remember, synthetic division looks upside down, doesn't it? Looks like upside down division. Yeah? Okay. What goes here at the top of synthetic division? 1, 10, 21, right? And what goes underneath the 21? Another little upside down box, and that is our remainder box, right? It's our remainder box, okay? So how do we do synthetic division? Oh, sorry, what goes on the outside? Why does negative 3? So you can think of it as the opposite as long as you realize we're thinking of it as the opposite because we're taking this and setting it equal to 0, right? Because if this said 2x plus 3, can I just put negative 3 out here? No, I would definitely have to set it equal to 0 and solve it and get 2x equals negative 3 and divide both sides by 2 to get negative 3 over 2, right? So I don't mind you thinking of it as the opposite as long as you realize it's because we solved this or set it equal to 0 and solved it to get negative 3. You okay with that? Okay. So let's remember the steps together and then I'll give you one to do by yourself. How's that? Okay. First one, we just bring it straight down. No matter what it is, we bring it straight down. Okay. Then I multiply. I write that number right here. And then I add. So 10 and negative 3, 7. Then I start all over. Multiply. Write that number right here. And then add. So if this is my remainder box, what's the one right next to it? That's my constant, right? What's the one right next to that? The x term. If there was another term over here, what would be next to it? And next to it? X to the third and x to the fourth. However many terms that were there, I would know what it was, right? So when I go to write my answer here, I have x plus 7. Yeah? Could I have done this problem with long division? Is there any restrictions on long division like there's on synthetic division? Okay, watch this real fast. X plus 7, x squared plus 10x plus 21. Well, if I divide the first term by the first term, I get x. Write it above the term that it's like. X times x is x squared. X times 7 is 7x. I subtract. I get 3x. I bring down my next term. Plus 21. Divide. Sorry. Divide the first term here by the first term here. What do we get? 3. Multiply 3 times x. Multiply 3 times 7. Subtract. So I did it backwards, didn't I? Okay. I said if we divide, synthetically, if we divide this by this, I should get x plus 7 as my answer. And then I kind of did it backwards. I didn't intend to. It was an accident. I'm sorry. If I took the original problem and divided by this, though, shouldn't I get this as my answer? Yeah? So let's take this back a couple days. What's true about both of these two things in relation to this original problem? What are they? Starts with an F and it's not the bad one. They're factors, aren't they? Okay? Both of these are factors. Now, this one for sure is a factor because it has a remainder of 0. But that also means what you got as your answer is also a factor. Okay? Any questions about that? All right. Let's go back to synthetic division again real quick. I'm going to give you a question to do. I'm going to write it for you on this paper. I'm going to give you a second to do it by yourself, and then we'll do it together. Okay? 5x to the third plus 6x plus 8. And I would like you to divide that by x plus 2. So how'd you set it up? Five, 0, 6, 8. You got to have a squared, right? You got to have a squared term. It's fine. I'll give you a second. It's all right. We're remembering this stuff. It's been a while. Tell me what goes on the outside. Negative 2. Good. Okay. Stop it. Stop it. Be nice. What'd you do with the 5? Straight down. And then? Get. And then? You just add, right? 0 and negative 10 is negative 10. Then what? And get. And then? Add. So you get 26. And then? And get. Good. And then? Add, right? Okay. So what'd you get as your answer? Remainder, constant, x term, 5x squared minus 10x plus 26. That's the answer? You got a remainder, right? So you have to have that as part of the answer. So how do I write that? Like that? I'm asking. Did you put the negative here or did you put the negative here? It does not. I'm just making sure you understand that. If I put plus a negative 44, that's perfectly fine. Or you could put 5x squared minus 10x plus 26 minus 44 over x plus 2. They are the same. Okay? You good? Any questions on long division or synthetic division? Okay, so what's next is evaluate a polynomial using the remainder theorem. So you know the remainder theorem, you just don't know that you know the remainder theorem. Okay? Because we actually just talked about it, just without talking about the name because we weren't ready yet. Okay? If the polynomial f of x is divided by x minus c, then the remainder is f of c. Hey, can you get that? Zach? Get that off the board. Thank you. So if the polynomial f of x is divided by x minus c, then the remainder is f of c. What does that mean? Let's look at this problem real quick. This is kind of where we talked about remainder theorem without talking about the remainder theorem. Okay? So what did we get for our remainder here? 0. So if I divide this polynomial by x minus c, see how this is negative c, right? Then what I should get for my remainder is if I put c into this equation. Can I show you what I mean? If I take, here's the problem, just so I have it in this part of the note so I don't have to keep referring back to that page. This was the initial problem, right? Okay? So if I divide this polynomial by x minus c, so in this case c is negative 3, right? Then f, the remainder is also f of c. So the value of this function at negative 3. So if I substitute in a negative 3, right here, I should get the exact same thing as this answer as I did for this remainder when I did the problem, when I did the division problem. Okay? Well, what is negative 3 squared? Negative 3 times negative 3 is 9. Good. 10 times negative 3? Negative 30 plus 21. What's 9 minus 30? Negative 21 plus 21? 0. Guys, what did I get for my remainder when I actually did the synthetic division? 0. Same thing. It's pretty cool, huh? Okay. Any questions about remainder theorem? So whatever C is, whatever I'm dividing by, I got to set it equal to 0 to find out what C is, right? So in this case, C was negative 3. I take that and substitute it into the equation that I'm trying to divide by. This will tell me what the remainder is going to be. Now, it didn't tell me what the answer was, right? The answer was x plus 7 when I did the synthetic division. It doesn't tell me what the answer was, but it does tell me what the remainder is going to be. So it does tell me that negative 3 is going to be, x plus 3 is going to be a factor of what I divided by. If this was like 5, well, that means this is not going to be a factor because there was a remainder when I did the division. Does that make sense? Okay. Any questions about remainder theorem? Good? Okay, then what about factor theorem? Have you ever heard of factor theorem before? You have, because we've already talked about it today. We just didn't call it factor theorem. Okay? So part of math stuff is knowing what the name of it is, because a lot of times you already know how to do it and what it is, you just don't know the name. Does that make sense? Okay. Factor theorem. Factor theorem says, first of all, let f of x be a polynomial. Okay, let f of x be a polynomial. There's two parts of it. Part A says if f of c is 0, kind of like we just talked about, then x minus c is a factor of f of x. Didn't we literally just talk about that? You just didn't know it was called the factor theorem. Okay. Part B. Notice what this says. First of all, part A. Part A says if you substitute in c to the function and it gives you an answer of 0, then you know x minus c is a factor of the function. Okay? Part B says if x minus c is a factor of f of x, then what? Can you tell me? It is. F of c is 0. Can you tell that that's kind of backwards of the first part? That's cool though, because if you know one is true, then you know the other is true, right? If when you plug in c to the function you get 0, then x minus c is a factor. But you also know then if x minus c is a factor, then you know that if you plug c into the function you will get 0. Does that make sense? Okay, so that's the factor theorem. So now what you need to do is use the factor theorem to solve a polynomial equation. Okay? This is something that we did in Algebra 2. I think you'll recognize it when we get there. We just didn't ever call it factor theorem because our book doesn't define it for us like that. Okay? So, here we go. 2x to the third minus 3x squared minus 11x plus 6 equals 0. And I'm going to tell you a little bit more information. I'm going to tell you 3 is a factor. Can I switch my words? This should say 0. You and I both know they mean pretty close to each other, but I want to use the right vocabulary. Okay? All right, if you know that 3 is a factor, what do you know to be true then? I should get a remainder of 0, right? So let's go ahead and do that. 3, so 2, negative 3, negative 11, and positive 6, right? So if I do the synthetic division here, I'm going to bring down the 2. I'm going to multiply and get 6. And then I'm going to add and get 3. I'm going to multiply 3 and 3 and get 9. And I'm going to add and get negative 2. I'm going to multiply 3 and negative 2 and get negative 6, which gives me 0. But I already knew that was going to happen, right? We all knew that was going to happen because it told us it's a 0, so we're good. Yeah? Okay. Well, what does that leave us right here? If that's the remainder, this is the constant, this is the, and this is the x squared. So 2x squared plus 3x minus 2 equals 0. Okay? Now, if the highest exponent is 3, how many answers should I be looking for? 3. Okay? Well, it already told me 1. I am trying to use the factor theorem to solve this polynomial equation. So I have now a quadratic I have to solve. And quadratics are way easier to solve than cubics, aren't they? Because now all I have to do is what? Oh, factor. Yay for factoring. How about if we do AC? What's AC? 2 times negative 2, negative 4. And what's B? 3. What two numbers multiply to be negative 4 and add to be positive 3? Multiply to be negative 4 and add to be positive 3. How about positive 4 and negative 1? Absolutely. So I'm going to, remember I rewrite this middle term. I split it into 2 parts. The 2 parts that you just told me. Positive 4x and negative 1x. Because then I can factor by grouping, can't I? Here and here. What's common in the first 2 terms? What should we factor out? 2x. What's left if I factor out a 2x? X plus 2, right? What do I have to factor out of the second 2 terms so that I get a parenthesis that says x plus 2? Negative 1, right? So if I factor out a negative 1, I end up with x plus 2 equals 0. Now what do these 2 terms, this one and this one, what do they have in common? X plus 2. If I factor out an x plus 2 from each term, what's left? 2x minus 1. Now I have these 2. What do I do with them? Set them equal to 0. Okay? So x plus 2 equals 0. 2x minus 1 equals 0. So if I add 2 to, or sorry, if I subtract 2 from both sides, I get x equals negative 2. Here I have a couple more steps, right? I have to add 1 to both sides first to get 2x equals 1. And then when I divide both sides by 2, I get x equals 1/2. Okay? Now, how many factors am I supposed to have? 3. 1, 2. Oh, 3. Okay? Now, your answer from this point is going to depend on what they ask for in the problem. Are they asking for the factors or are they asking for the zeros? Okay? Because if they're asking for the factors, there's 1, there's 2, and the other one is here, x minus 3. That's the third, right? 1 is here, 2 is here, 3 is here if they're asking for factors. But if they're asking for zeros, what are they wanting? This, 1, 2, 3. 1, 2, 3 if they're asking for zeros. So remember, if they're asking for zeros, a lot of times they want it in set notation. And they also want at least to greatest. So negative 2, 1/2, or 3 if they're asking for zeros. Okay? So just be clear on your vocabulary, what the problem is asking you for, so you know how to answer it. Any questions? Look over the objectives again, please, and make sure that you don't have any questions about any of the specific objectives. You good? All right, peace.